So, welcome to solving quadratic equations by factoring. I believe this is going to be like the sixth lesson in our series. So, remember, quadratic equations are those second-degree equations. In other words, that exponent was a 2. Third-degree equations are actually called cubic equations. So, if the highest degree is a 3, we call that a cubic equation. And again, in this section, we're going to use what we call factoring as a strategy. So remember how we did some of that. Before we get into that, though, we do want to talk about what real numbers are. So real numbers are defined as either rational or irrational numbers. When we refer to rational, we talked about whole numbers, integers. Those are considered rational numbers. And of course, rational kind of meant any number can be expressed as a fraction, which of course whole numbers and integers can be. Also, we mentioned decimals. Decimals are rational as long as the decimal is a terminating or repeating decimal. So terminating means the decimal has to end like 2.5, or repeating like 1/3 turns into like 0.33333 repeating decimal. So those are types of numbers that are considered rational. Irrational numbers are going to take on this look. Like pi is considered irrational. The square root of 5 is considered irrational. The cube root of 12 is considered irrational. Because when you turn these into decimals, pi is a crazy decimal that goes on forever, but most of us round it to 3.14. The square root of 5, again, if you turn it into decimal, it's going to be some decimal that does not terminate, nor does the decimal repeat. The numbers are random. The same with cube root of 12. So that's why we kind of call these irrational numbers. They kind of are strange looking if you put them down as decimals. Also to bring to your attention of the square root symbol. Now in math, like I said, adding and subtracting are related to each other. Multiplying and dividing are related to each other, because remember, they're basically just thinking backwards of each other. So when it comes to like 5 squared equals 25, if I go the other direction, I can say the square root of 25. And what the square root of 25 means is what did you actually square to get 25? And that would be, of course, the 5. So that's what we mean by the square root. Root kind of means the origin. What number did we actually square? And that would be our answer. So 5 would be that. So notice how 2 cubed is 8. If I go the other direction, this is referred to as the cube root. So the cube root of 8. So if I take the cube root of 8, that's going to take me back to what was actually cubed that gave me 8, which was the 2. So again, this little 3 is called an index number, and this symbol here is called the radical symbol. So down here, when I have 3 to the power of 4 equals 81, 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So 3 to the 4th is 81. If I go the other direction, the inverse of the power of 4 is the 4th root of 81. So in other words, what was raised to the power of 4 to get 81? And that would be 3. So again, the 4 is called the index number, and that we have that radical symbol there. So notice how in this situation, since I got whole numbers, these actually are considered rational numbers. It's when I can't take the square root or cube root with a whole number that it becomes irrational. We'll talk more about that later. Another thing we want to bring into your attention is this multiplication property of 0. So we learned that if you multiply by 0, the answer is 0. So what this is saying, if 0 is a factor, then the product is always 0. So notice how if you have this a times b is equal to 0, a represents a factor, b represents a factor. So for it to equal 0, either a's got to equal 0 or b's got to equal 0. That's important to us. So what this takes us to then again is just, we're going to be solving equations, and some things to pick up on is a first degree equation, in other words, a linear equation, it has no more than one solution. So if you recall the last lesson we did, we were solving linear equations, and if you notice, we were only getting one answer. Now we're going to start working with second degree equations, which we call quadratic, and they're going to have no more than 2 solutions. So a lot of our answers are going to have 2 solutions in them. And in the cubic equations, when the highest degree is 3, we're going to have no more than 3 solutions. So the degree also helps us understand how many solutions there are. And again, a lot of times we're going to be using these words roots and or zeros in talking about that. So roots or zeros stand for the solutions to an equation. So when we move into quadratic equations, the strategy we're going to talk about is solving by factoring. Remember, a quadratic equation has to have the quadratic term. So this term here has to exist, the x squared term. So this term has to exist for it to be quadratic. If it disappears, then it's no longer quadratic. So whatever degree we have indicates what type of equation it is. So A, B, and C are going to be some type of number. Again, x is our variable that we're going to be solving for. And again, we're going to be using this multiplication property of 0 as our strategy to solve quadratic equations by factoring. So remember, A is a factor and B is a factor. All we got to do is pick up on that. If one of those is 0, then the whole thing becomes 0. So to solve x squared plus 5x equals 0, we're going to use factoring to solve that. In this particular example, what it has is a GCF. Notice how there's an x squared term and a 5x term. They both have an x in common. So I'm allowed to pull out the x, and that's going to leave me then this x plus 5. Now that it's factored, we just set each individual factor equal to 0. So x equals 0, and the x plus 5 equal to 0. And then all we got to do is solve these two equations. So notice how x equals 0 already has x by itself. To solve this one way is to just use your 0 pair. Put a negative 5 here as long as you put a negative 5 over there. After doing that, you're going to start to see patterns on this. So x is going to equal then this negative 5. But if you notice, if you just look at it, x plus 5 is equal to 0. X would have to be a negative 5 just by looking at it. We know that a negative 5 plus 5 has to be 0. So I really don't need the property of equality. I should be able to just write down the answer x equals negative 5. So let's now take it to this next level. Solving equations like this. So we have this 3x squared plus 14x minus 49 equals 0. I've been a big fan of this 4 square thing, but I'm discovering it's not all cracked up for these types of questions here. So let me go ahead and show you 4 square on this problem. So notice how, again, it is a quadratic equation because it's set equal to 0, and there's a quadratic term. There is a GCF here, unfortunately. The 3, the 14, and the 49, there's no number in common, and they don't have an x in common either, so we're stuck with those 3 terms. So in using 4 square as my strategy, draw my 4 square. We get the right color here. So let's see here. We have a 4 square. So when I use 4 square, what I'm focusing on is my quadratic term goes in the top left. My constant goes in the bottom right. The catch is, since there's a coefficient in front of the quadratic term, when we make big T, you actually got to multiply 3 times this negative 49. So when I multiply 3 times negative 49, may need a calculator for that, we get this negative 147. So when I use big T, it becomes not so good because we get a crazy number to start with here, negative 147. But using a calculator, we can manage it. So remember, the factors of the negative 147 have to add up to be this 14. So again, we have 1 and 147, but that doesn't look like there's any way that's going to come together as a 14. 2 is not going to work because 147 is not even. And since 2 doesn't work, no even number is going to work. So if I go to 3, I do get 49, but 3 and 49, there's no way it seems like that's going to give me a 14. So again, 4 is out, 5 is out as well because 147 doesn't end in a 0, 5, 6 out. So now we're up to 7. 147 divided by 7, that saves me some time. So I did get a 7 and a 21. That looks like that would give me 14. And since I need a negative 147 and a positive 14, that 7's got to be negative. So when I do this, my linear term gets broken apart using this negative 7x and this 21x. Now the next thing on this problem, since there is a coefficient here in front of the x squared, what we do is pull out the greatest common factor of the top row. So the 3x squared and the negative 7x. And since they have an x in common, I bring that there. And then we just try to piece it all together as a puzzle. So if I have x here, what factor I need up here would be, I need a 3x there. That would give me 3x squared. If I have an x here, I need the negative 7 here. That would give me negative 7x. If I have a 3x up here, I need a 7 here because 7 times 3x is 21x. And 7 times negative 7 is negative 49, so that checks out. So the edges become my factorizations. So x plus 7 times then this 3x minus 7. And that's going to equal then this 0. So this may not be the best way because of that negative 147 becomes a pain in the butt. So x plus 7 has to be set equal to 0. 3x minus 7 has to equal to 0. Again, notice that I can just look at that and say, well, negative 7's got to be the solution there. On this one, notice there is a pattern here as we do this. The negative 7, I'm going to have to add a 7 here and add a 7 over there. So when the negative 7 cancels, it's going to appear on the other side as a positive 7. So I'm going to have this 3x equals 7. And then you're going to have to divide by the 3. So to make the 3 go away, it becomes the denominator on the other side. So I end up with then this x equals the 7/3. So we start to see a little pattern there with that. So the negative 7 goes over as a 7, then the 3 slides underneath and makes that negative, makes that 7/3. So negative 7 and 7/3 would be your solutions to that problem. So if I look at this next example, 6t squared minus 42t plus 72 equals 0. Notice again, it is a quadratic equation because of the 6t squared, and it is set equals 0. So the strategy is going to be to factor. And notice that hopefully this, if we can make this coefficient go away, that's going to be cool. And if you look, 6 does go into 42, and if I use my calculator, I believe 72 divided by 6 does give me a whole number as well, that 12. So 6 is a GCF, and they don't have a t in common, so the only thing I can bring out is a 6. So the 6 comes out, which means I'm left with this t squared. 6 goes into 42 7 times, so it's going to be a minus 7t. And 6 does go into 72 12 times, so I'm left with a 12. Now, since the quadratic term is just t squared, we can go ahead and set up our two sets of parentheses. It's only hard as if there's a coefficient in front of the quadratic term. So I know that a t and a t have to appear in this problem. Now the catch is, what are the factors of a 12 that add up to a negative 7? So again, a lot of times this is your most common factors. You know, the 1 and 12, not probably going to work. 2 and 6 is a possibility, but that don't look like that's really going to give me a 7. That 3 and 4, that looks pretty good. So now I just have to fix the signs so that it gives me a negative 7. So if I make that a negative and that a negative, that does give me a negative 7, but also has to give you that positive 12. And we do know that a negative times a negative is a positive 12. So that all works out. So that negative 3 and that negative 4 are going to be the factors that I use to build the rest of the factoring. So I'm going to have a -3 here and a -4 here. So now we just set the factors equal to 0. But notice when I set 6 equal to 0, that's a false statement, so we just throw that out. T minus 3 is equal to 0. We just have to figure out what makes that true, and 3 would make that work. T minus 4, what's going to make that equal to 0 would be a 4. So we would just say T equals 4. So 3 and 4 would be the solutions to that quadratic equation. So we have x squared plus 15x equals -56. Notice again, it is a quadratic, but it's not set equal to 0. So my first move is to set it equal to 0. And to make a -56 turn to 0, we have to add a 56. But we also have to add a 56 to the other side. And it really doesn't belong anywhere because it's not a like term. That's going to probably become our constant. So I have this x squared plus this 15x plus this 56, and that's going to equal this 0. So again, we have to set it equal to 0 before we can start factoring. In factoring, since the quadratic term is just x squared, we can go straight to parentheses. So the only way to get that x squared is x times x. Now the catch is, what are the factors of the 56, the constant, that add up to give me this linear coefficient, which is a 15. So again, if you know your math facts, think about it. What's the most common way of getting 56? If you know that 8 times 7 is 56, then you can kind of bypass going down through there, because that 8 and 7 really seems to fit that 15. So if you know your facts, that's pretty good. You don't have to list all of them. So that 8 and 7 really looks good because 8 times 7 is this 56, and 8 plus 7 is this 15. So it's going to complete my factorization. So I'm going to put a plus 8 here and a plus 7 here. And again, that's set equal to 0. Now that I have it factored, we just set each factor equal to 0. So x plus 8, I'm sorry, we don't need no parenthesis though. So we have then x plus 8 is equal to 0. We have x plus 7 equal to 0. And so now I need to solve for x, so that's got to be a -8 because -8 plus 8 is 0. This has got to be a -7 because a -7 plus 7 is equal to 0. So that would be my two solutions, is -8 and -7. So as I solve this quadratic equation, again, notice how it's not equal to 0. So if we lose a 3x here, we also have to lose a 3x over here. And these actually are like terms, so I could probably line that up a little bit better. So I can put a -3x here. And then we just simplify and bring down the new equation. X squared plus 14x plus 49 is equal to 0. What jumps out at me again is this is a quadratic equation. And since the quadratic term is just x squared, I can just kind of go straight to parentheses. So x and x would give me my x squared. And then we're looking at the factors of 49 that are going to add up to be this 14. Again, there's not that many factors of 49, and if you're pretty good thinking about it, if you go through it, you're going to see that a 7 and a 7 is going to be a 49, and 7 plus 7 is 14. And I do need them to both be positive. So the factorization would be x plus 7 and an x plus 7 equals then this 0. So x plus 7 and x. So what you do is set each factor equal to 0. So x plus 7 is equal to 0. X plus 7 is equal to 0. So this has got to be -7, and this has got to be -7. So let's say we have two answers, but it actually is the same answer. So really, there's only one solution to this equation, and that's -7. And sometimes that's called a double root. We may hear about that more. So now we want to solve this 3x squared minus 192. Well, I'm hoping that this 192 is divisible by 3. So on my calculator, I'm going to go ahead and type in 192 divided by 3 and see what happens. It does. It gives me 64. So 3 times x squared minus 64 becomes my new factorization. Notice how we have again is x squared minus 64. That is a difference of squares because 8 squared is 64. So I can go x, but I need a minus 8 and a positive 8 because remember, that's going to make my linear coefficient turn to 0. In other words, there is no linear term in this problem. And that's why, because when you do multiply it out, the 8x and the negative 8x are going to 0 out there. So again, we can set each factor equal to 0, but notice how again when you set 3 equal to 0, that's not true, so we just ignore it. So really all we have is this x minus 8 equal to 0, and this x plus 8 equal to 0. So we solve for x, 8 minus 8 would equal 0, so one of the solutions or roots would be 8. And what would make this turn to 0 would be a negative 8. So negative 8 plus 8 would be 0, so that would be my two solutions or my roots. Now, some equations will look not quite quadratic. But remember, in working with equations, we still got to manipulate them a little bit. And if they turn into quadratic equations, then we have to follow quadratic strategies. So remember, though, our solutions must work for the original equation. So this is our original equation. And notice how there's a x in the denominator. That means we have some exclusions. So note that the denominator, if you set that equal to 0, well, that means we can't have 0. Because if you do, that would make the denominator 0, and that crashes the question. So the problem will not work with that. Now that we've noticed that there's this exclusion, to get rid of the fraction, we have to multiply by the LCM of the denominator. Well, since there's only one denominator, we know that the LCM has to be then just this x. So we're going to multiply each side by this x. But remember, you have to put each side in parentheses to do that. So on the left side, notice how we have to distribute the x through the parentheses. So this becomes then this 6x squared minus this 5x. And on the right-hand side, notice that the x's will divide out and just leave you a 6. Now, if we set this to 0, we have to subtract 6 on both sides. Lose a 6 here, lose a 6 here. So let me see here. Just draw the line. So if I clean that up, we're going to have 6x squared minus the 5x minus the 6, because those aren't like terms. So they have to both come down. And then the 6 and the negative 6 would have zeroed out. So I have a 0 on the right-hand side. So again, we do have a quadratic set equal to 0, but we don't have a greatest common factor here. So one of the strategies, again, is we can factor. Again, we can try to use 4 square. I'm not having much luck with it this time around. Let's see if I have any, see what happens here, if I have any more. So when I draw my 4 square, the quadratic term goes in the top left. The constant goes in the bottom right. The reason I'm doing that is because there's a coefficient in front of x squared. So the catch is, when I create the big T, the 6 and the negative 6 have to multiply together to give me my big T. So I have this negative 36 that has to give me this negative 5. So the factors of 36, again, I'm not sure on these. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which pair looks like would give me a negative 5? It looks like that 4 and 9 looks pretty good. But one of them's got to be negative. It looks like that 9's got to be negative. So in doing so, what I'm seeing is a 4 and a negative 9, if you multiply those together, they're going to give me that negative 36. And if you add them together, they're going to give me this negative 5. So I'm going to be using those to complete my 4 square. So 4x is going to go here, and negative 9x is going to go there. It doesn't really matter where you put them. Um, now that I've done that, I can't just start building it. I need to know what goes to this top spot here. And what we do is we just find the GCF of the top row. So the GCF of a 6x squared and a 4x would be actually a 2x. So when I do that, then there's got to be a 3x here to get my 6x squared. I need a 2 here because 2x times 2 gives me my 4x. So from there, we have, I need a negative 3 here because that's going to give me my negative 9x. And negative 3 times 2 does give me my negative 6. So that checks out. So my factorization is going to be this 2x minus 3 and this 3x plus 2 is equal to 0. So now I got to set each one equal to 0. So 2x minus 3 is equal to 0. And I have to set 3x plus 2 equal to 0. So doing this, x is going to equal, notice the negative 3's got to go over and the 2's got to go underneath. So it's going to be 3 halves. X has to equal, the 2's got to go over, but it's going to be a negative 2. And the 3's got to go underneath. That's going to be negative 2/3. So that's going to be my solution is 3 halves and negative 2/3. So if you start to see patterns, you don't necessarily have to use the property of equality, just follow the pattern. So now, this brings us to third degree equations. What we're going to do here is, since there's going to be 4 terms, we're going to use grouping as a strategy. I usually use what's called the box method for me. It just helps me see things better. So I'm going to draw a box around the first 2, and I'm going to draw a box around the second 2. This usually works for most of the things we're doing. So again, we're going to create these 2 binomials, and what we're going to do is factor a GCF out of each box, out of each binomial. And so looking at the first pair, x cubed and the 4x squared, I do see that they each have an x squared in common. So I pull that out, that leaves me an x and a 4. Now, when there's a negative in this position here, where there's just negative here, in this position, what we do is we go ahead and pull the negative on out, which means these 2 signs are both going to change when I do this. Notice that a 16 does go into 64, I believe. 64 divided by 16 is 4. So I am going to pull out a negative 16. I'm going to pull the negative out as well. In doing so, these signs are going to switch. So this is going to become then just simply x. And instead of a minus there, it's going to turn into a plus. And as we said, 64 divided by that 16, or negative 64 divided by negative 16, is going to be that positive 4. So it does check out. Now that we have it factored like that, what we look for is now the binomial that's in common. So notice how they both have this x plus 4 in common. So that's the next thing I want to do is pull it out in front. So the x plus 4 comes out in front. And then what's left in is this x squared minus 16. And again, this should be set equal to 0. I keep forgetting that. These are equations, so I have to set them equal to 0. So once I do that, notice the x squared minus 16 is still factorable. It's a perfect square. That 16 is. So this is actually called a difference of squares. Once a difference of squares, we just write x and x to get the first term. And since 4 squared is 16, we put down a minus 4 and a plus 4 there. And of course, this is set equal to 0. So now we've got it factored. We just set each factor equal to 0. So x plus 4 is equal to 0. X minus 4 is equal to 0. And x plus 4 is equal to 0. So our solutions would be, well, that's got to be a negative 4, because negative 4 plus 4 is 0. That's got to be a positive 4, because 4 minus 4 is 0. And that's got to be a negative 4. So notice that we do have 3 solutions, but 2 of them where one of them is the same. So I have a -4 twice. So really, there's only two different answers there, a 4 and a -4. So this is a 4, and that's a -4. All right. So let's do another one of these. So x cubed minus 8x squared minus 4x plus 32. Again, feel free to pause the video and see if you can work it out in front of me. So again, I'm going to, since it's 4 terms, I'm going to put a box around the first two. I'm going to put a box around the second two. And then I'm going to find the GCF of each one of those. And again, notice how when I have that second box, there's this minus sign right here. What I want to do is pull it out as well. So there's a 4 also in common, so I'm going to put a -4 out. So that makes this x, but the sign's going to change to a negative, and 32 divided by 4 would have been an 8. So now I'm looking for a common binomial that x minus 8 is in common. So I'm going to pull the x minus 8 out, and then I'm going to have this x squared minus 4. Notice how again it's a difference of squares, because 2 squared is 4. So the x minus 8 is okay, but the x squared minus 4 is factorable. It's a difference of squares. It's going to factor into x minus 2 times this x plus 2. Now that it's factored, we just set each individual factor equal to 0. Okay. And then we just solve each one of those equations. So 8 minus 8 would be 0, so that's got to be 8. 2 minus 2 has got to be 0, so x has to equal 2. -2 plus 2 is equal to 0, so x equals -2. So remember, a cubic equation can have up to 3 answers, and we do have 3 different solutions there as our solutions. So this next page we have, or the next question, I have to solve 2x cubed plus 16 plus x squared plus 32x. So it looks like it's got 4 terms, but they're not all on the same side. So my first move is actually to set it equal to 0. So I'm going to lose an x squared here, but I got to lose an x squared over here, but it doesn't really belong anywhere. I have to lose this 32x, so I have to do that over here. And also, there really aren't any like terms, so I have to bring on down all 4 terms. And we want to bring them down from highest degree to lowest degree. So 2x cubed, this -x squared, this -32x, -32x, plus then, that looks a little rough, plus then the 16, and that has to equal now 0 since this zeroed out and this zeroed out. So we're left with 0 on that side. So notice how, again, it's got 4 terms. So again, if you want to pause the video and see if you can get this one worked out. So I'm going to box in the first 2. I'll try to box in the second 2. Just watch out for that subtraction sign. So again, I want to find the GCF of each grouping. So again, the x squared would come out here. So it's going to leave me a 2x minus then this 1. Notice how again there is this little negative floating out here, out in front. We don't like the negative there, so we're going to pull it out in front all the way. When I do, the signs have to flip. So we also pick up on that there was a 16 in common, because 16 does go into 32. So that's going to make this become a 2x, and the sign flips to a -1. And this does create a common binomial. So the 2x minus 1 becomes in common. So I'm going to pull out the 2x minus 1. And I'm left with this x squared minus 16 equals 0. Again, the 2x minus 1 is not factorable, but the x squared minus 16 is a difference of squares. 4 squared does give me that 16. So it's going to be that x minus 4 times this x plus 4, and that's going to equal then this 0. Now we just set each factor equal to 0. So 2x minus 1 is equal to 0, x minus 4 is equal to 0, x plus 4 is equal to 0. So the 1 is going to slide over, 2x equals 1. The 2 is going to go underneath, x equals 1 half. Here we just have 4 as a solution, and here we have a negative 4 as a solution. So again, since it's third degree, we're looking for up to 3 solutions, and we do. So our last topic is a quadratic application. So a ball is thrown vertically upward from the top of a building 48 feet tall with an initial velocity of 32 feet per second. The distance s in feet of the ball from the ground after t seconds is represented by the equation 48 plus 32t minus t 16t squared equals s. After how many seconds does the ball hit the ground? So if I want to just kind of sketch this out a little bit, um, we have the ground here, and there's this building that extends up above the ground. It's above the ground by 48 feet. It's 48 feet tall, so it's 48 feet off the ground. So here, this would actually be a height of 48 feet. Now, from there, a ball is thrown vertically. So from here, a ball is thrown vertically. So it's going to go up with an initial velocity of 32 feet per second, but it's going to slow down because of gravity. That's where that negative 16 is coming into play. It's the gravity that's pulling it back down to the earth. And it's going to splat on the ground here. So when it's on the ground, notice that its height's actually going to be 0. So when it says after how many seconds does the ball hit the ground, I don't know the time, but I do know that the height is going to be 0. So when I rewrite this equation, I like to go ahead and put this in the correct order for me, which would be the negative 16t squared plus the 32t plus the 48, and that's actually going to equal 0. Again, I don't like the quadratic term's coefficient to be negative, so I'm going to factor it out as well. And each one of those, the 16 does go in each one of those, I believe. 48 divided by 16, yep, that's 3. So we pick up on that. So I'm allowed to pull out, I'm actually going to pull out the negative as well. So by doing so, that's going to leave me then inside the parentheses. I just pull out a negative 16, nothing else. So the negative 16 comes out. So that's going to leave me a t squared now. That's going to turn into a positive. This plus is going to turn into a minus, and 16 went into 32 twice, so it's going to be a minus 2t. And that sign's also going to turn because of the negatives being pulled out. And so 48 divided by 16 was a 3. So it's going to equal then this 0. So now this negative 16 stays put, but t squared minus 2t minus 3 is a factorable quadratic. And since the coefficient of t squared is just 1, we just make 2 sets of parentheses. And remember, the t squared just gets broken apart into the first positions, t and t. But the factors of the negative 3, the factor of the constant, must add up to be the coefficient of the linear term, which is at negative 2. So the factors of that negative 3 must add up to that negative 2. Again, there's only one pair of factors for 3, 1 and 3, 1 and 3. And to be a negative 2, this 3 would have to be negative. So what I have then is t plus 1 and t minus 3 is my factorization. Now set each factor equal to 0, but again, when we put that negative 16, so I have negative 16 equal to 0, that just means nothing. So really all we have to focus on is t plus 1 is equal to 0, and this t minus 3 is equal to 0. And what can you add to 1 to get 0? Well, that would be a negative 1. And what can you subtract 3 from would be a 3. So 3 minus 3 would be 0, negative 1 plus 1 is 0. So I get these two answers, but which one actually makes sense in this problem? Negative 1 seconds or 3 seconds? Yeah. So when you throw the ball from the roof of the building, the top of the building, it's going to take 3 seconds for it to hit the ground. The negative 1 would not make any sense in this application. So even when you get the answers in application, the answer's got to make sense. So next question is, after how many seconds will the ball pass the top of the building on its way down? So here, what they're talking about from my picture is now we're throwing the ball, it's hitting its high point, and what we know is when it passes by the building again. So we're looking for when the ball is about here. Notice how, again, the height off the ground is going to be that 48. So when I do this, we actually do know the height. Height off the ground, we do know what S is, we just don't know what T is. So that's all we have to do is be able to apply that. Luckily, we don't have to write this formula. So again, I'm going to rewrite it the other way around. We don't need this color here, though. So I'm going to make that negative 16t squared plus the 32t plus the 48. And that's going to now equal 48, since we're talking about when it passes the building on its way down. So when I do this, what we pick up on is we need to set this quadratic equation equal to 0. So I need to lose a 48 here as long as I lose a 48 over here to set it equal to 0. So the negative 48 and those will 0 out. The 48 and the negative 48 will 0 out. So over here, the negative 16t squared comes down. The plus 32 comes down. 32t comes down. But notice how the 48, negative 48, 0 out. So that's all we have. So this is what we have left. And notice how it is a quadratic because the quadratic term did not disappear. So if it's a quadratic, our strategy is to use factoring. And again, notice how that coefficient of the quadratic term was negative. I want to pull that negative out. And notice that 16 is a factor of both of those. So I'm going to factor the negative 16 out. And that's going to leave me then this t squared. But since I factored out, I'm sorry, that's not right either, is it? They have a t in common too, don't they? So not only do they have a negative 16, but they have a t. Okay. Whoa. Okay. So I should have a negative 16 come out, negative 16t come out. That leaves me a t and a minus 2. Yeah, that looks right. Now we just set each factor equal to 0. So negative 16t, set that equal to 0. And t minus 2 equal to 0. This one over here looks a little funny. So if I just go ahead and use strategies, if I divide each side by negative 16 to make that coefficient equal to a 1, do the math, the 16s divide out and turn into a 1. 0 divided by negative 16 would be 0. And t minus 2 equals 0, that looks more familiar. That would have to be a 2. So there's my two answers, 0 and 2. But remember, this is time, 0 seconds and 2 seconds. Which one would actually answer this question? Yeah, 0 would mean we're still on the building. So when it passes by the building, it would actually be the 2. So the 2 seconds would be when it passes by the building on its way to the ground. All right, so that concludes our lesson for solving quadratic equations and cubic equations using factoring.